Welcome everybody. We are given the system. We are asked to find the modulus of x added with modulus of y. And the given system is 54x positive 72y is equal to negative y over x squared positive y squared, followed by 72x negative 54y is equal to x over x squared positive y squared. I'm going to take this system 1 and system 2, and I will be using complex numbers. So we know that the complex number is of the form z is equal to x positive iy. And what I wish to do is I would like to multiply system or equation 1 with I and add it to equation 2. So let me write that down. So this is I times 54x positive 72y is equal to negative I times y divided by x squared positive y squared, followed by 72x negative 54y is equal to x over x squared positive y squared. These two are added, and that would give me, I'm going to write this term first, 72x negative 54y positive I times 54x positive 72y is equal to x negative I times y divided by x squared positive y squared. Now I am going to connect these two together. So I take x out, I would get 72 positive I times 54, followed by connecting these two together, I take y out. This is going to be negative 54 positive 72 with the I there is equal to x negative iy divided by x squared positive y squared. This is what we've got. Now we know that in complex numbers I squared is equal to negative 1. So I'm going to retain this, or I'm going to replace this negative sign with the I squared. So I get I squared times 54 positive I times 72 times y positive this term x times of 72 positive I times 54. Now I would like to take a I out. This is going to be I times y of 54 times I positive 72 followed by x times 72 positive I times 54 is equal to x negative iy divided by x squared positive y squared. Now clearly you got 72 positive I times 54, 72 positive I times 54. So that can be taken out. 72 positive I times 54 can be taken out, giving me x positive iy is equal to x negative iy divided by x squared positive y squared. Now what I wish to do is I would like to consider x positive iy times x negative iy. This is nothing but x squared, positive times negative will give me negative I squared times y squared, which is equal to x squared positive y squared. So I got a term x positive iy times x negative iy is equal to x squared positive y squared. What I wish to do, I would like to push this term down. So that would mean I have x positive iy times x negative iy divided by x squared positive y squared is equal to 1. I would like to push this term now down. That would mean I have a 1 over x squared positive y squared is equal to 1 over x positive iy times x negative iy. Now I wish to multiply the numerators, both sides, by x positive iy. No, I will multiply it by x negative iy. X negative iy, x negative iy. Both sides by x negative iy. Why do I do that? I want to get rid of this term. So I would now have x negative iy divided by x squared positive y squared is equal to 1 over x positive iy. Now what is this x positive iy? This is 1 over z. So in place of this term I can utilize 1 over z. So let me go back to this system here. If I were to take this as 3, I can rewrite 3 as, therefore 3 can be rewritten as 72 positive I times 54 times, now you see there's an x positive iy, so let me take it as z, and that is equal to, in place of x negative iy divided by x squared positive y squared, it's going to be 1 over z. Now I can push this z down, so this would mean I got 72 positive I times 54 is equal to 1 over z squared. Now let me consider this term. Let us assume that 72 positive I times 54 is of the form sum a positive ib raised to the power of 2, because this is a complex number, right? I'm just taking this to be of this form. Now this is nothing but a squared negative b squared positive I times 2ab. Now which would mean 72 is equal to, equating the real and the imaginary part, 72 is equal to a squared negative b squared and 54 is equal to 2ab. So this means ab is equal to 2 divides 54 2 times and 7 times. ab is equal to 54, I mean ab is equal to 27. That's only possible if a is equal to 9 and b is equal to 3, provided of course this is satisfied. So you take this value and you substitute it here. So this is equal to 9 squared negative 3 squared. So 9 squared is 81, 3 squared is 9. You push 1 there, it's 11, 9, 10, 11. That's going to be 2. You carried 1, so it's going to be 7. So 72 is equal to 9 squared negative 3 squared. That's perfectly correct. So a is equal to 9 and b is equal to 3. So this would mean 72 positive I times 54 can now be rewritten as 9 positive I times 3 raised to the power of 2. You see that? This is now the new representation. So what I need to do, I need to take this up and I need to substitute it there. So let us do that now. So I need to name this system, right? I take it as 4. So therefore 4 can be written as 1 over z squared is equal to, in place of this I am having 9 positive I times 3 raised to the power of 2. Now this can be further rewritten as 1 over 9 positive I times 3 raised to the power of 2 is equal to z squared. Therefore if you were to push the square to the other side, z is going to be plus or minus 1 over 9 positive I times 3. So I am going to rationalize this. I'm going to, don't worry about this plus or minus, let it be as it is. We can rationalize the term inside. So this is multiplied with 9 negative I times 3 divided by 9 negative I times 3. So this is going to be plus or minus 9 negative I times 3 divided by 9 squared is 81. This is plus and minus negative, I squared is already a negative 1, that's going to be positive. 3 times 3, 3 squared is 9. So this is equal to plus or minus 9 negative I times 3 divided by 81 added with 9, that's going to be 90. Now this can be rewritten as plus or minus 9 over 90 negative I times 3 over 90, which is equal to plus or minus 1 over 9 divides 90 10 times negative I times 3 divides 90 30 times. So it's 30. This is how you get. So you got a x term and a y term, right? On the left hand side it's going to be x positive iy. So equating the real and imaginary part, you get x is equal to plus or minus 1 over 10 and y is equal to plus or minus negative 1 over 30. We need to find the modulus of x added with modulus of y. So modulus of x, if you were to take the modulus of x, that's going to be 1 over 10. Modulus of this quantity, that's going to be 1 over 30. Now let me just place the values of x and y When I take the positive value, this is going to be 1 over 10 followed by negative 1 over 30, and when I take the negative end, x comma y is going to be equal to negative 1 over 10 and 1 over 30. But we need the modulus of x and y. So if you were to take the modulus for this, there's going to be 1 over 10 added with 1 over 30, which is going to be 30 and 3 positive 1, which is equal to, let me write the solution here, I hope you can watch the solution, is equal to 4 over 30. So that's nothing but 2 over 15. So that's a solution. So probably I will just place the solution here. So modulus of x positive modulus of y is equal to 2 over 15. That's the final solution. I hope you enjoyed this working. Until we meet again, everybody, enjoy your day.